So, test 1, sample problem 3. 3 students are looking at 3 different solutions to a problem that includes the resolution of vector A into components as shown. Aisha says only solution 1 is right. When we resolve a vector, we have to break it up into the x and y components so that the components add up to the original vector. Bashir says solution 3 is also right because the components still add to vector A and this vector still form a right triangle. And Claudio says all 3 are right, the only difference is the choice of coordinate axes, and that will depend on what is most convenient for the problem solution. All of these students make good points. Sadly, none of them are correct. So let's see what has gone wrong, or at least what's different. So Aisha is certainly right that when you resolve a vector, this is true, that when we resolve a vector, we break it up into its x and y components. Certainly true, so that the components add up to the original vector. And that is true. So solution 1 is perfectly fine, and solution 2 is perfectly fine. But Aisha is incomplete. Bashir is wrong because the components do still add to the vector. That's still true. And they do still form a right triangle, but both of these are missing an important part, which is that the component vectors, the subvectors, have to be at right angles. All right, the components are always at right angles. So if we look over here, we say, oh, that's okay, AX and AY are perpendicular. And over here, AX and AY are perpendicular. But for Bashir, unfortunately, AY is not perpendicular. There's no good symbol for that, but not perpendicular to AX. We know that because it is perpendicular to A, so it can't be perpendicular to AX. That means that this one is unfortunately no good. But none of the students are right because it turns out that this is also okay. Even though the components are not horizontal or vertical, they are still at right angles, as marked explicitly. So vector resolution 1 or resolution 2 are both correct resolutions of A.